The next thing we're going to look at is the sine rule. The sine rule can be used to find both sides and angles. We're going to concentrate on finding sides here. The sine rule will be given to you like this in your formula list. What it's telling you is it's telling you the ratio between a side and the sine of its corresponding angle is equal for the three sides in our triangle. So basically, if I take the value of A and divide it by the sine of A, it's going to be the same as if I took the value of B and divided it by the sine of B. And if I took the value of C and divided it by the sine of C. So those three results would be the same. So what this allows us to do is this allows us to find a side or an angle provided we know a pair and the side or angle that corresponds to the one we're trying to find. So for example, if I was trying to find the value of A, I would need to know the angle A, and I would need to know either B and the angle B, or I would need to know C and the angle C. Okay, so I don't need to know both of these pairs here, don't need to know both of these pairs, but I need to know at least one of them to help me find this missing side. So, here's a typical example. Find the size of the side marked X. I can see this is a problem where I have to use the sine rule, as I have got an angle with its corresponding side, and the side I'm trying to find has a corresponding angle. So I've got these sort of pairs set up. So I'm going to start by writing down the sine rule. A over sine A equals B over sine B. I don't really need to write the third pair, and I'm not really going to worry too much about these labels A, B and C here. What I'm interested in is these sort of highlighted pairs. So the thing I'm trying to find, X, I know that, over the sine of 52. So I've got this side I'm trying to find and this angle that corresponds to it, so on the opposite side of the triangle. And that is going to be equal to 12 over the sine of 34. Again, the 12 corresponds to that angle there. I've got an equation here. I'm trying to figure out X. I've got X divided by the sine of 52 is equal to all of this here. Sine of 52 is just a number. So if I want to get my X on its own, I can multiply each side of my equation by sine 52. And that will cancel out that divided by sine 52 there. So that will give me X equals 12 over sine 34, and all of that times sine 52. Now, again, a decent scientific calculator can let you type that all in a oneer. So there we go, typing that in gives us a big long number. We'll round that, as I've done with the rest in these videos. I'm going to round that to three significant figures. So 169, the 1 means I'm going to stick, I don't need to round up. So 16.9, these are in millimetres, so X will also be in millimetres. Now, here's another slightly trickier example. I've been asked to find the size of the side marked X. It looks almost identical to the one on the previous page in terms of how it's set up. I mean, looking straight away, I've got a side here, and I've got the corresponding angle, and then I've got this X, and I've got another angle. However, X does not correspond to that remember our corresponding sides and angles need to be opposite from one another. So 42 millimetres is directly opposite from that 102. X, the thing we're trying to find, we actually need to know that angle in there. That 27 would only be useful if I was trying to find this side here, which I'm not. So I need to find this missing angle. Luckily, we've got a triangle with two of the angles in it already. So I actually just need to do a little bit of basic arithmetic to find this missing blue angle. So the angle FEG, the one I've got highlighted in blue there, is going to be 180 subtract the other two angles added together. So the angle FEG, so that should be 51. I've got a nice decent sized diagram, so I'm actually going to write that 51 in. Now I've got a pair of angles and sides I know, and I know the angle that corresponds to the side I want. So I can go ahead and use the sine rule. So just writing down the first pair from the sine rule there. Again, not worrying too much about using the letters that are actually on this triangle. A over sine A, well, I want to find x, so that'll be over sine 51. And that is going to be equal to b over sine b, so the side 42 over the angle, or the sine of the angle, 102. I'm trying to get the x on its own, so I need to get rid of divide by sine 51, so I'm going to multiply by the sine of 51. That is going to cancel out that division, and I'll be left with x equals 42 over sine 102, and that is going to be multiplied by sine 51. So typing that into a winner into my scientific calculator gives me the answer. Again, I'll stick with three significant figures, so 333, and the 6 means I need to round up. So my 333, that rounds to 334, so that'll give me x equals 33.4 millimetres. So here, with this problem, the trigonometry, this bit, exactly the same as the one on the previous slide. However, we've got to do a little bit of work to get a useful angle inside our triangle. So it's quite common for problems like this to be have lots of lines round about them. I mean, another way this problem could have been presented is like this. So yeah, like this, where we have got a triangle, but it's got this little extra extended line here, and you've got to do a little bit of, what you call angle chasing. I mean, we don't actually have any pairs here, so to find x, I would need to know this angle. 42 doesn't have its partner over here, so we have to do a little bit of sort of basic angle work here. We've got a straight line, so that would have to be 51, because these two angles would need to add up to give me 180. Then in the yellow triangle, we now know 2 out of the 3, so you could find that third angle there by subtracting the 51 and the 27 from 180 degrees, and that would give you 102. So there can be a little bit of angle chasing involved with these sine rule problems.